I want to start with the static nested class because I think it's the easiest to use and understand. The static nested class is a class enclosed in the structure of another class declared as static. This means the class, if accessed externally, requires the outer class name as part of the qualifying name. This class has the advantage of being able to access private attributes on the outer class. The enclosing class can access any attributes on the static nested class, including private attributes. Let's look at this in code. I've created a new project called Nested Classes for this video. I'll first create an employee class in the packagedev.lpa.domain. I'll add 3 attributes, the employee ID, name and year started. I will generate a constructor with no arguments. I also want another constructor, this time with all 3 fields. And I'm also going to generate a getter, but for the name field only. And after that, I'll generate a toString method. I'll replace the template code for this method with my own formatting and include the 3 fields. That's a simple domain or business domain class called employee. In the past section, I created a comparator class to sort students, and I'm going to do something similar for this class. I'll create this in the same package as employee and call it employee comparator. I want this to be generic and accept any employee or subtype of employee. To do that, I need to include a type parameter, so T extends employee. I'll add implements comparator for that, using employee as the type argument. To get rid of that compiler error, I'll implement the compare method. Because I included a getter for the name field, I can use that getter to compare names between 2 employee objects in this method. I'll replace the return 0 statement with code to do that. Next, I'll set up a few employees in the main class's main method in a list. List of type employee named employees equals new array list, diamond operator, and I'm going to pass a list of employees generated by the list.of method. New employee with a unique ID of 10,001, name of Ralph and year 2015. Next one has 10,005, Carol, and 2021 as arguments. Then 10,022, Jane and 2013. 13,151, Laura and 2020. And lastly, 10,050, Jim and 2018. That's 5 new employees created and added to our array list. I've not created them in any particular order. I'll sort our list with my comparator, create a new instance of our employee comparator, and pass it to the employee sort method. The comparator local variable I created can be inferred when I assign a new employee comparator instance to it. If I hover over that variable, you can see it's a comparator typed with the employee class. I then pass that to the sort method. To confirm the list is sorted, I'll print out the employees for each loop over employees and print. Let's check that we're sorted OK. You can see our list of employees are sorted by their names, which are printed out left justified. Now let's say that I instead want to sort by the year the employee was hired, the year started field. Going back to the comparator, I'll comment out the statement that's currently there. Let's attempt this using year started. Compare year started for each employee by returning the result of deducting 02 year started from 01 year started. But this doesn't work because the year started is private on employee, and this class employee comparator is external to the employee class. To get this class to work with year started, I'd need to either change the access modifier for that field or provide a getter for it. Maybe there are reasons I don't really want to do that. I'll revert that code, removing that last change and uncommenting the first statement. I now want to copy that whole class from the class name to the ending closing brace. I'll jump over to the employee class and paste the code at the top of this class. I'll add the keyword static between the public and class keywords. What I'm doing here is creating a static nested class inside of the employee class. This code compiles, so let's go back to the main method and use this class. First, I'll comment out these, the 2 statements, the first that creates a comparator local variable and also the employees.sort statement that takes the comparator variable. I'll add a statement which is very similar, but instantiates and passes the comparator to the sort method. The only difference is that I need to specify that this comparator is accessed through the employee class, so employee dot before the employee comparator class. Call employees.sort, passing the static employee comparator. Notice I'm using the diamond operator there, but it's empty because Java can infer its type. Let's run this now. I get the same results. So that's good. But if I go to that nested class, I have extra options available that I didn't have with the external class. First, I can access the attributes on instances of the employee class directly, even the private ones. So I'll update this method, and instead of calling getName, I'll just access name directly. I can replace getName with simply name in both cases. Let's make this comparator more flexible. I'll add a private attribute to it called sortType. I'll generate a constructor with one argument for the new sortType field. I also want a noargs constructor, so I'll generate that before the previous one. For this constructor, I just want to chain a call to the other constructor, passing name as the default sort type. Finally, I'll make the compare method figure out how to sort based on the sort type field. Are we comparing by year started? If true, return the result of 01.yearstarted minus 02.yearstarted. Now, if I go back to the main method and run it, it should run as it did before because sorting by name is the default sort type. Next, I'll pass year started to the comparators constructor. Running that code now to verify what happens. You can see that our employees are sorted by the year they started. I also want to remind you that the comparator interface has a default method called reversed, which I will use next by chaining it to my current comparator. Let's run the code. You can now see that the employees are sorted by year descending, so that's a nice feature. The reversed method will reverse the sort for any comparator. To create a static nested class, you add a class as part of another class's body, making it static. This lets you access it via the class name, like other static variables. But this nested static class has access to all the outer class's private members, and vice versa. Using a nested class for this comparator, I was able to keep my attributes encapsulated without needing to provide getter methods for each one. In the next video, I'll take a look at the inner class, again using a custom-built comparator as our use case. See you in the next video.